steel, all kinds of metals. So it's really quite revolutionary for all industries, and we're going to talk about what's happening in aviation. They're also using it on the space station. Much easier to have a 3D printer on the space station and make parts and wait for one to come. So it's really changing. And Mike is going to talk about how Piper is using 3D printing, but they are using it for not just plastics for interiors of aircraft, but also for fuel nozzles and turbine blades and things like that, which raises all the issues that we're going to talk about today and probably not have too many answers for you. So Mike's going to talk a little bit about what 3D printing is in the aviation context and generally, and Laura's going to talk about FAA regulation. Mike's going to talk a little bit about how Piper has gone about getting certification for what they're using 3D printing for. I'm going to talk about product liability implications and then risk management. Lily will follow up with insurance implications. So Mike, do you want to take it away with, can we change it again? Just this?
Oh, just keep it.
Yep. That is an industrial size 3D printer. So I know most people think it's small, it is not. And then these are just some of the products. There's a gun on the right, I see some on the left, some medical device on the upper right, and space station, big basic kind of advantage of the space station. So Mike, do you want to take it away? I have your slides up.
Okay. My name is Mike Gordon. I'm the Director of Quality and Process Engineering with Piper Aircraft. That's my day job. The side work I do as a consulting engineer for Joe with RTI, and I do a couple things here and there. One of the items that has been near and dear to Piper's heart lately has been trying to go through and take cost out of airplane manufacturing. Additive manufacturing that's out there is a relatively new manufacturing process, and as the name suggests, you're adding materials together. This process itself, you start with a three-dimensional CAD model, and then you're going through and are taking powders or extruded materials, and you are recreating that three-dimensional shape in a printing environment. Originally, it started out with just extruded materials, and it's kind of expanded into other plastic powders, and then even going into the metallic realm, where you are starting out with plastics, and then you're sintering these materials to make metallic parts. Collectively, the technique is called additive manufacturing, because like I said, you're adding material. It's the converse of subtractive manufacturing, where you would have, a large billet of material that you would go ahead and put onto a milling machine, let's say, and then go ahead and machine the parts out. You have a lot of waste. The idea behind additive manufacturing is, precisely build up the material you want. One of the neat things about additive manufacturing, though, is not only can you print parts, but because of the tight tolerances, you can have in manufacturing these parts in proximity to each other. You can actually make working assemblies in a single printing operation. A part that would require successive part manufacturing using a subtractive technique, you would then have to come in and bond together to make a finished part. Well, with 3D printing, you can do it in one single operation. They go to page 7 on these charts. You guys have all been on airplanes, and you casually sit there. I would have been sitting on one yesterday, going to Aviation, had it up in the storm. The little things like an air conditioner duct that's there. You don't really think much of it. You see the louver section, but behind that louver section there is a little plenum box. And that little plenum box you see there in this drawing. This is a picture of the interior panel. It's a drawing of the interior panel on the pilot side of their M600 aircraft, or Malibu-class aircraft. And you have a small air conditioner duct there. And on the back side, there's a cross-section showing the inset, showing you that behind this louver, you have this little box. And the little box is presented there to the right side. It seems rather remarkable. You have this hose inlet that gets connected to the round section, and then it goes into this plenum box, into this receiver that's there, that it clicks into the diffuser assembly that's visible. This box box located on the inside of the panel. But it seems like a rather unremarkable little part. Well, if you go ahead to the next page and you look at what's there, that receiver we would buy from the louver manufacturer company, and they had this little cuff on there. Well, we'll go ahead and buy this part, and we'll cut the cuff off to have it be a flat part. Then we go ahead and we inspect that part, and we store that part in the warehouse. And then we go ahead and start making other parts. And we'll go ahead and look at the table full of tools that are there, that are various thermoforming tools that are used to form the various plastic shell components that are all put together in this small assembly. We use solvent welding operations to piece everything together, and at the end of this, with the labor that's included with all the manufacturing effort, this little funnel box cost nearly $200. It's about $183 if I think the numbers are right. We had 12 different tools, and we had several different operations to go ahead and do that. We go to the next page, and we get into a 3D printed part, where we're taking the part on an HP 4200 printer, and we're printing it out. We're actually printing several of these things out in a media of powder itself. So we'll take this box, we'll put the powder in there, and then the 3D printer is made by HP. Most of you guys, when you go home, you'll have an HP printer in your house. It's just little inkjet, little tremendously expensive liquid ink cartridges that are in there. The technology is such that you'll take, rather than having red ink or cyan ink or anything like that, you'll have a black ink that's precisely deposited in the powder along with a gray ink. And these two inks that are being applied will focus radiated energy at the site and will locally fuse the powder into making this part. And it does it by each layer. It slowly builds the part up. But the end result, I have a part that ordinarily cost me $200 that I'm able to go ahead and make now for about $10. Now, the part itself, the geometry of that part is, a artifact of the constituent parts that were used to make the piece up. I can come back and really start to refine this model to really make the part more efficient, to use less material and to actually alleviate dead spots. And I can get the price of this part to go down to almost $6 a piece. And compare that to the $200 it once it cost. It clearly shows that it's worthwhile going down that path. But the important thing is you just can't go ahead and take an expensive part and make it cheap and say that that's okay. So the way, on page 10, the way the small airplane directorate and Piper, the way that we worked out the way of satisfying the regulatory requirements for making airplane parts, you look at the regulations that are there. For small airplanes, it's Part 23. For the larger transport category, it's Part 25. And the helicopters, it's Part 27. But they're all the same regulations and the same theme. So this approach would work for anything. Your 601 regulation, you have to produce a test plan. Go ahead and talk to your ACO office to let them know, hey, we're looking to go ahead and get production approval for us using this particular part. And then you have to explain that you're using it for parts, whether they're structurally significant or not structurally significant. And in the case of aircraft interiors, you look at the regulations that are there. Flammability is a big deal. Smoke and toxicity is a big deal for the Part 25 airplane. But you go through and you put a plan together. In order to satisfy 603, which is your material and workmanship requirements, you have to go ahead and construct a material specification for those powders we talked about. So that's fairly straightforward to do. 605 is our fabrication method. So we have to come up with a process specification where we go through and really discuss how we're printing to make sure all the critical variables in that printing process are captured in the specification. And the key piece there is that we have close process controls to consistently produce sound structures. That's what the FAA is really interested in. If the material does have a structural significance, if we are carrying some load, let's say we have a secondary structure in there where we're required to have a design allowable set up for it, 23613 comes into play. We'd have to go ahead and develop design properties. So we go to our 3D printer, we would go ahead and print up an we have to make sure we're meeting these material strength values. The last regulation we have to work on is the 853, the flammability requirements. And there we go to our 3D printer once again and print out a 3 by 13-inch burn specimen. And we go ahead and conduct horizontal burn testing for small airplanes or vertical testing for larger. Demonstrate that we meet our flammability requirements. And then from a certification standpoint, we're good to go. It's really that straightforward, that simple. It kind of takes from the composites world and showing compliance for the regulations. And the key to the whole thing is really communicate with the FAA, make sure you're using this material in a fail-safe manner, and make sure that you have process controls that you are always printing the correct material, using the correct powders in the correct way.
Thank you, Mike. I have
Any questions?
Lisa, I have a question. So do you actually do the CAD, the computer-aided design? Your engineers there?
Yes, there's a couple of different ways that we can do it. Of course, we use Unigraphics or Siemens Unigraphics as CAD application, but we could use CATIA. The idea is that you would have a 3D model. That's the more traditional way of modeling things. We also have a Creaform Metroscan 3D, which is a three-dimensional scanner that has a scanning volume that's about, I want to say 10 foot by 15 feet by about 8 feet high. And you can scan something in that volume with about 5/1000th of an inch accuracy. We then have that surface that we scan, and we can translate that into a CAD model and then go right into printing. So if I wanted to go through and replicate a part, or let's say I have a part, tool that I used to use for laying up composite parts, I can scan that tool, get the surface that's in there, and then finish my engineering of the CAD model on that surface to have, clean the model up a little bit, and then I can go right into printing again.
Okay, well,
they're very efficient.
Okay, I think we're now going to look at the larger issues in certification. Let Lauren go ahead and tell us something.
Sure. So Mike gave a great discussion of sort of the ground level, what it's been like for Piper dealing with the regulations. I'm going to take it up to a 30,000-foot level on how the FAA has been addressing the certification issues related to AM additive manufacturing. Because we're talking about the aviation space and going to use additive manufacturing instead of 3D printing. The FAA will take you more seriously if you say that. So that's my goal, is always to get the FAA to take me seriously. So as you all know, aviation products are subject to a comprehensive federal regulatory scheme that governs them throughout their entire lives, from their initial conception through their entire service lives. FAA establishes those safety standards for the design and manufacturing of the products. If you ask me, those are exclusive standards. We can talk about that later in the drinks. Congress empowered the FAA to examine any aspect of the product that it wants to relevant to safety. And Congress has expressly recognized that aviation products are regulated to a degree non-comparable to any other industry. And those standards are intended to maintain the safety and the integrity of aviation products that we're dealing with. So there's a lot of different places that AM is being discussed in the aviation space, from tooling to component parts to parts themselves. And if we're dealing with components or parts, certification is implicated, and that's as opposed to generally to tooling. And we're expecting down the road more and more safety critical parts to be developed and using AM. So we're dealing certification, as I'm sure you all know, the FAA has a pretty comprehensive scope from the type certificate for certifying the actual design of the product, to duplicate the product, we need to obtain a manufacturing certificate, and that includes having an appropriate quality system to make sure that you are producing duplicates of that production certificate, right? So make sure you are producing appropriate duplicates of the type certificated product. Then FAA actually certifies the aircraft, the airworthiness cert, making sure that it meets the type certificate and it's in a condition for safe operation, and then has conditions for continued airworthiness if those products will get out in the field and are flying. So with components, you might have something that is part of a type certificated product, or you might be dealing with a replacement or modification part. So if you're dealing with a component part that's part of the type certificated product, it's going to be certified under the framework of the whole type certificated product. If it's a replacement or a modification part, it might be subject to a parts manufacturer approval or a PMA, or if you're actually modifying a type certificated design, you might be dealing with a scheme or a supplemental type certificate. Gamma experts disagree with the contention that, at least for right now, we're looking at active manufacturer entire airplanes for quite some time. And they also generally suggest that, at least for the foreseeable future, we're not going to have AM completely supplant traditional methods of manufacturing in all areas just because of the efficiency in certain spaces. So we'll see AM in a lot of spaces, and potentially more and more as that technology develops. But for now, we're probably going to have a mix of AM and traditional manufacturing. And Mike, if you hear anything that you don't agree with from your end, jump in and correct me.
No, you're spot on. Even the manufacturing that we're doing right now, we're still in the prototyping phase right now. We're going through the process of getting approval and then working closely with our ACO to go ahead and get them to approve the work that we're doing. But a big part of that is to follow those regulations that I laid out and do exactly what you're saying and have demonstrated evidence that you're complying with those regulations. And that's a big part of it.
Yeah, so if you have, just like Mike was saying, if you have a component, the way that the FAA actually certifies that design is as part of the whole product that you're certifying. So they're going to issue a design approval based on whether you comply with all the regulatory requirements holistically for the design, including that particular component. I just wanted to note, which I'm sure you're all familiar with, that it's implicated in the ultimate scheme of failures of these products, but FAA and EASA also monitor the life of the products and service and track any issues and can issue airworthiness directives to correct an unsafe condition in service. So broadly, what does this all mean for the certification of additive manufacturing? Generally, the regulations that we're dealing with have been written for traditional manufacturing, but that's not. Some of this isn't entirely new. We have had different kinds of manufacturing methods come in not too distant past, like composite manufacturing, and we've been moving more and more in aviation regulation to performance-based standards, which makes more flexible applications for manufacturers. The real challenges for certifications that we're dealing with are the complexity and the lack of maturity that additive manufacturing presents, and the fact that AM is not a single process, that you have many different processes that are going to have different specifications. So because it's a newer technology in some respects, you have some limited understanding of the acceptable ranges and parameters for manufacturing, and limited industry specifications and standards. And because a lot of this is proprietary information, we've had some difficulties with information sharing across companies to develop those standards. For airworthiness, our primary concern from the FAA standpoint is repeatability and consistency and quality. And since you're producing something without those general industry consensus standards to date, there's some challenges in getting the acceptableness of that. Another thing to note is there's an expectation that AM is going to lower barriers to entry to the aviation manufacturing marketplace, and that might bring some new players into aviation manufacturing who might not have as much familiarity with the aviation product regulatory scheme, which presents its own challenges for regulators because the FAA is a small organization for the scale of safety obligations that it has. It relies heavily on the expertise of the manufacturers in many respects to conduct some of its safety obligations, including with the designee processes. So at least to date, no rule changes are anticipated. The FAA has really taken on a mandate to develop an appropriate roadmap for additive manufacturing. In 2017, they released their draft strategic roadmap. For that, it was developed in conjunction with industry, and that roadmap is intended to assist the FAA in both regulating the certification and maintenance of AM parts, and as well as sort of delineating their R&D goals, their educational goals, and their training goals for themselves and for industry. Industry is also working closely together. Some of our main standards bodies in aviation, like ISO and ASTM, are collaborating to develop AM roadmaps and standards themselves. And AIA has led a working group to support FAA in developing certification guidelines. So that's sort of where a lot of this is in flux right now. The work is ongoing to sort of help the FAA in figuring out the appropriate standards for addressing certification of AM parts, but it's rolling relatively quickly. There's only one other point I want to make before I turn it over to Lisa for talking about what this all means for litigation and product liability. But the FAA not only certifies parts, it's also responsible for detecting counterfeit parts that aren't certified or parts that were properly manufactured and don't meet their certification specifications. And the way that it actually conducts the detection is largely through aviation community reports, accident investigation, and its general surveillance activities. You've probably seen that there's a number of things written about some limitations in this framework to detect unapproved parts, which are called suspected unapproved parts, SUPs. And there is a suggestion that additive manufacturing could exacerbate the problem of suspected unapproved parts, both from improper manufacturing and from a counterfeiting standpoint. So, what that means for the FAA's ability to handle that, since they're already challenged in handling it without large use of AM by entities that might be interested in these sorts of activities, it's going to be a challenge for them.
Thank you, Lauren. Ted mentioned earlier, the three of us, together with a lawyer in Europe who's going to focus on what's going on there, are in the process of writing an article, which we'll let you know when it's finished. That's going to go much more in depth in all of these areas. But we did a quick overview if you want to pick it up on your way out. In terms of product liability, whether it's aviation or medical devices or any other industry that is using 3D printing, there's no case law. There's not been, that we can find any litigation involving a 3D printed part in the product liability area. Where you see litigation right now is more on copyright or IP level. So no case law. And so a number of questions come up with 3D printing. And I have a client who is a 3D printing company. They make 3D printing printers. And the typical scenario for them is they do some aerospace work. And they have the printer. They work with aircraft manufacturers who want interiors for their aircraft. And so they have the printer, and they work with the engineers of the manufacturer to come up with a computer-aided design, a CAD, on what that's going to look like. They do the printing at their facility, my clients, not the manufacturers. I'm not sure who chooses the materials, probably a combination of the two. And then they sell it to the aircraft manufacturer. But often, I think we're going to be seeing a much longer supply chain when you're dealing with component parts being manufactured. So you're going to have the people who own the printer. You're going to have the people who came up with the design, whether it's a combination of the manufacturer and the printer manufacturer, or just the printer manufacturer, or just the designer. You're going to have the people who supply the materials and say that these materials are what they're supposed to be. And then you have your supply chain. So as a plaintiff's attorney, I'm looking at potential targets if I think there's been a defective part. So where are the targets there? There's a whole new line of potential targets. What is the product? Is the product the design, or is it the finished product, or something in between? And if it's the design, well, under the restatement, a software is not considered a tangible product. So you might not be able to apply traditional strict product liability laws to the design part of it. You may have to look at negligence theories. You're going to have to look at whether there's counterfeiting or there's something else involved. Since you're dealing with computer-aided design, was there a problem with malware or some other cyber security issue that impacted the eventual part that was allegedly defective? So it opens up a whole new realm of potential legal theories. I think it also opens up a whole new realm of potential experts that we're going to have to find. And then in terms of risk management, Lily's going to talk about from the insurance perspective, but you're also going to have numerous contractual provisions going throughout this whole chain. You're going to have lots of different contracts, invoicing, and you're going to have different contracts. And there are going to be a lot of shifting of the risk within these contracts. So you're going to look at indemnification provisions, you're going to look at the warranties, you're going to look at choice of law provisions. So, but there's going to be multiple contracts now, so maybe just two. So I'm afraid more questions than answers, but it's going to come very fast. And as I said at the earlier technology panel this morning, it's another instance of where the technology is much more ahead of the law. So just something to be thinking about. And so when you're thinking about it, also think about how you can insure against this.
And so, since we have the board, I'd like to not to oversimplify, but just to outline kind of the chain that we're going through. We have our idea, right? So that's a light bulb. And that would be, the person that comes up with the design, the professional, right? They're your engineer. And then you have your software, right? And then down here, you have your printer. And you have thing, the widget, whatever it is. And so your typical CGL policy will cover bodily injury, property damage, personal injury arising from product, right? So here's your widget. But what is the product? So this changes things a bit. And then, are you covered under your typical CGL policy for security breaches, data breaches, hacking? And are you covered for professionals that are not regulated? And typical CGL policies won't cover something like data breach. But there are limited circumstances where they will cover things like accidental publication of information of that type of data breach. But for corruption of files, we want something more all-encompassing. So I think a broader way to think about it is here's where you want your, here's where you want your cipher. Very nice, where you're thinking of your typical CGL. That makes sense. So it's a nascent stage where you kind of want to, as a risk manager, I think, envision all the places along the chain where things can go wrong. And there are a lot of places where things can go wrong. And it's exciting, but it's also, things to think about, and want to make sure that people are covered, and it's the job of, you need to know what risks that you need to be managed.
And Lil and I were talking earlier, this is really not on the radar screen, certainly of a lot of claims people, but even on underwriters, aviation underwriters, when they're just starting to think about 3D printing, and they're saying, not a big deal, maybe there's a big deal. But now they're starting to see all the different products that are being prototyped, as Mike was saying, in the aviation industry, and thinking, maybe I should be looking at this a bit more closely. And then risk managers obviously have to be thinking, maybe I need multiple policies, so multiple coverages. So it's a brand new world. It's very exciting, I think. For the manufacturers, it's certainly very cost effective in the long run. We were talking about, we might want to talk a little bit about for maintenance and repair operations, what that might mean. And the one legal issue that you're seeing.
So in some ways we think of this
this might extend the supply chains, but I'm sure you've seen discussions of this significantly reducing the chains, because you have folks who are going to be potentially making parts in-house that they previously had to have supplied or stock. And that has some real benefits for maintenance facilities that might have difficulty stocking parts that are either can't leave on the shelves or it just doesn't make sense to keep a lot of them. And depending on what you're doing and what your authority is under the regulatory scheme, certain maintenance operations can fabricate parts. And 3D printing obviously has some real benefits if you could fabricate a part when you're conducting a repair or alteration within the scope of your authority as a repair station, an FAA repair station. But because those folks won't be doing that all the time, there's some challenges presented there for the repeatability issues that we have with a manufacturer like Mike, setting up his quality systems to try to make sure that every time you're making a part, you have the consistency and repeatability. And even if you're fabricating a part one-off and test that part for its strength and its functionality to meet what you intended, will the next part that you make actually be the same as that original part? And are your tests actually valid for that next part that you fabricated for putting on there? So in terms of what this means for product liability and the quality of the things that we put in, we think there's a lot of opportunity for awesome developments in aerospace that's going to make very flexible, adaptable, inventive products, but a lot of questions right now about how we prevent against having unknown quality issues introduced into a very safe system for aircraft.
Are there any questions or things that come up? Or things that would come up that we should all be thinking of? Go ahead.
I have a couple of comments to make, and so Mike, I'm in maintenance. I think in theory, your plenum explanation of being able to make it for $10 versus $200 is cute, but the cost of the tooling to get there may actually end up costing more than $200 to make than, like I say, in theory, $10. So, I mean, obviously...
You go ahead and consider, if you're in maintenance, the overhead latch on the Cherokee, there's a cam system where we have this plastic injection molded cam that if we find that the mechanism itself needs to be adjusted at all, the easiest thing for me to do is to adjust that cam. The thing that prevents me from doing that is that it's a blow molded part that we buy 1,000 of them at a time. And in order for me to make any modifications to that tool, it's about a $20,000 hit.
Correct.
Go ahead and do that.
Right, I'm familiar with it.
If I can 3D print the part and I need to have the ear section of the cam have a little bit or more or a little bit less material, it's easy to go ahead and do that modification. Accept the part on a material review board disposition. Assemble the part, verify functionality, and go. And it's awesome.
Right, yeah, and I agree with what you're saying, and I think that's what's going to drive your cost factor. I mean, we're Americans, and not to be insulting to us, but American greed. Why would I want to make it for $10 when I've been getting $200 now? So I might as well make it for $199 and make the world think that they're saving a bundle. Okay, so, and if you need that part, by the way, I do stock it, and I know they're hard to come by. Now, just gamma-wise, I mean, I understand what you're saying, and again, in theory, but operators, their own airplane, they are allowed to make parts.
Absolutely.
And I think what you're going to find here is going to be a lot of owners, because I've had it brought into my own shop. Mm-hmm. You're going to have a lot of owners that are going to start building their own airplane. I mean, but literally, I'm not saying a kid airplane.
Yep.
They're going to start supplying legitimate shops like myself with parts, put this on my airplane, and it's going to be hard to fight them in the sense of the word, should I lose another client?
No,
in my company's case, it's a yes, I couldn't care less.
Yeah.
But, I'm big. So, that's a problem I think that you're going to have, because I know for a fact, and I'm going to use the company's name, that the Commander aircraft, where getting parts right now is as hard as finding hen's teeth.
Yep.
So all of my commander owners, Ace Hardware and Home Depot is just a very large supply house for them, along with making their own parts. So I mean that's a battle that you're going to have when these people start having their own 3D. And,
absolutely. And
respectfully, I'm saying that to you, and not out of any disrespect.
No,
I thank you for the
Except
presentation.
you just violated the TC of the aircraft.
you did, but
You can't stick an Ace Hardware part on it.
so
Pardon?
You cannot stick an Ace Hardware part on a certificated aircraft.
but
I see it every day.
yeah, I think
That makes it
that's
legal.
kind of an interesting aspect of how much of this is a new old problem. So some aspects of this are very novel and new and exciting, and then other aspects of it are same issues that we've always
Fuel
been
pumps
having.
on your pipeline.
Exactly.
Come off one assembly line, one's STC, one's on.
So,
Same pump.
we do already have people putting parts that they're not supposed to be using on aircraft. Will this make it easier? Maybe. Depends on whether or not they can afford the printers, depends on the availability of that information. I think that that's one of the real challenges that we've all been talking about, that I think from the product liability standpoint is going to be explaining why two parts that look exactly the same from the outside but were processed very differently, and the processing has different implications for the integrity of them. So they can look the same, they have the same form and function, but not the same integrity, are different to a jury. So, I copy this one and this one, and now does that mean I can hold this person responsible for this? Probably not when you actually understand why these are very different, but if you don't understand that, this looks the same as that. So was the original design holder responsible for a replacement part that they did not make? The design.
On a side issue of what you diagram.
Right, and as a manufacturer, we don't have the benefit of being able to go ahead and set somebody up on a PMA.
Exactly.
Go ahead and make a part that we design. It's just these things are happening rogue. I mean, that certainly is an issue from an OEM standpoint.
On a coverage insurance and all that issue, are you seeing a change in the indemnity agreements to where if you're the widget guy, you're going to make sure you have a very good indemnity back up the chain for software and cyber issues and all the way back to design?
So I haven't seen it yet, but that is certainly an issue. And I would think that encryption with the software is a particularly important issue, because just like there are serial numbers on manufactured parts today, with software, I think there needs to be some kind of protection and identification to prevent that kind of copying.
Other questions? Did you have a?
One thing I didn't quite follow. So, as of now, what general kinds of parts or components has the FAA actually approved for use?
Yeah, so we have AM is being used in blades. There's a very famous GE fuel nozzle case that has been approved. A lot of use in interior work right now, use in tooling. So in addition to just using for direct manufacturing, AM provides a lot of opportunities for actually making tooling to produce things using other methods of manufacturing. Mike, you want to weigh in on some parts?
The question was chopped up, so I had a hard time hearing what the question was.
He's asking what's actually existing in service that FAA has blessed from AM.
From the small airplane directory standpoint, that they go through and they issue what's called a small airplane issue list or a sale. And they're in the process right now of saying that additive manufacturing is something that's out there that they're concerned with. They are actively working on draft policy and guidance for the use of the new and novel technology. We're going through and basically laying out what we want to do in reports and tacking it onto an issue paper in order to get the FAA's attention trying to deal with this. And, using the analogs that are out there from the composites world and, believe it or not, the welding world, we're able to go through and make a case for putting together a certification plan on discrete parts. But those parts really, right now, for us, are limited to, and I don't want to call them decorative parts, but they are interior parts, they're secondary parts, and they're not carrying light loads. They're not parts of such a high mass that they become an inertial issue during a crash or anything like that. So the smaller parts, let me tell you, from a manufacturer standpoint, the money is there. The price of these printers that we buy, we can show an ROI on buying one of these printers in about 7 months. It's pretty astonishing. And, you have two of these machines. This just tells you the trajectory of the technology. I have two of these machines. If one of them breaks, the other printer can print out a spare part for the broken machine. The technology is unbelievable.
It's interesting there. It's also being used in accident investigations from the NTSB. Their materials lab has a scanner and has a printer, and they're using it to produce both models as well as produce parts to compare to failed parts. So another application in aviation.
And there are some examples in the paper, the short paper we wrote, but Safran has received European certification for a turbine blade nozzle for the EAPU 60 on the Leonardo AW189. There's one. Also, there are fuel nozzles. GE is making fuel nozzles using 3D printing, and I'm pretty sure it's been approved. But there's a big task force over at the FAA looking at this. It's coming.
And some of the folks you talk to are like, this is not new. Composite manufacturing has a lot of AM-related elements, and like Mike just said, welding has, you're putting things together. So there's an odd mix of, this is something we do every day in aviation to the sky is falling, this is completely new and what's about to happen. So
you said the NTSB's got their own 3D printer. But when you take an OEM bumper off your vehicle, when you take a aftermarket replacement, they look identical. They have the exact same specifications, except one can withstand a 20-mile-an-hour hit, and the other one fractures at 5. So how can the NTSB know they met the manufacturers?
they're not using them for testing the strength of the product. They're using, for example, they had a rail accident and they made a 3D model to show what had happened in the manufacture. So there was a failure in the actual material that was manufactured, that was whole in whatever the product looked like in one part of it. So they made a 3D model to be able to explain what had happened there. And then they're using for sort of form comparisons. So this is what the product's supposed to look like. They're not using it for structural testing or something like that. They're using it for...
The work I've done with the guys over at the lab in Mont Plaza there, they do use it for making exemplars and things like that, what the part should look like, what the associated adjacent part should look like, trying to recreate a mechanism. They use it for like I said, exemplar purpose.
Yeah. I mean, you just look at what's been in the news lately with the gun. You know, they say, oh yes, they can use plastic and make this gun, which you're not going to be able to shoot once. But the idea is that people are going to start using metals to make real guns, and that could be very complex, including AR-15s. And there's no restrictions in place. Anybody can print them. You know, felons or terrorists or whatever. What was really scary is that it was almost went forward until there was an injunction. But
You need reasonable machine shop to make an AR-15 anyway.
Anyway, so I think it's very exciting, but I think something, no matter what your perspective is, everybody should be aware is coming or is here, and what the risks are and what the questions are. So hopefully we educate a little bit.
Thank you very much.